Joining us today is Dr. Andrew Bullmore from Horley. Horley is the largest and latest addition to the Tetra Tech family of the high performance buildings group. This 900-person engineering firm was established in 1862 and has some of the smartest and brightest engineers and building scientists in the world. Our keynote speaker, Dr. Andrew Bullmore, is an expert on advanced control systems and real-time monitoring. Next slide. We're all part of the High Performance Buildings Group, which is a division of Tetra Tech, a public company. And we have over 3,000 engineers and scientists. Next. So Dr. Bullmore is going to kick off the presentation. Emer Maloney is going to talk about existing buildings and how we improve their performance. Cameron Sandell, the director of smart buildings at NDY, is going to talk about new buildings and strategies that we can employ today. Tom Collins from Horley is going to talk about the future and new technologies that are evolving and being beta tested. And then with that, I'd like to turn it over to Dr. Andrew Bullmore. Dr. Bullmore.
Steve, thank you very much. Next slide, please. I'm very glad to be part of the High Performance Buildings Group, as Steve has just alluded to. We might want to define high performance buildings. They might mean many different things to many different people, but effectively they are buildings which simply deliver what they're designed to deliver and are sustainable for both people and the planet in the face of today's demands, and are also resilient to future changes. So next slide, please. So I'm going to start today to talk about the imperative, why we want to engage, why we're striving for better performance outcomes from buildings. And if I just summarise three key areas that I think we need to think about, there's the climate crisis and the spotlight that this has shone on building energy performance, now brought into even sharper focus by the global energy crisis. There's the impacts of COVID-19 and the need to deliver quality indoor environments for human health and well-being. And there's the need for reliable evidence of building performance for property portfolio investment and management decisions, including the retained value of built assets as we shift from this traditional carbon-based economy to a low-carbon economy. Next slide, please. Of these drivers, few, I don't think, would dispute that the most urgent is the climate crisis. In this context, buildings really do matter, and the statistics there really do speak for themselves. You know, buildings being responsible for about 40% of the emissions driving climate change. However, of course, being part of the problem conversely means that the built environment is equally part of the solution. And this is especially the case when we recognise that from a people perspective, our ability to tackle the climate crisis requires an otherwise healthy and economically sound and sustainable society, which in turn, of course, is founded on the very built environment that is contributing to the climate problem. So looking to where we are in terms of our energy reduction, the reduced use of fossil fuels in decarbonising the energy market is key to delivering future benefits. But it's only part of the answer, certainly as far as the built environment's concerned. Current best estimates are that grid decarbonisation will realistically only get us about 40% of the way towards our goal of operational net zero carbon as far as the buildings are concerned. So if you, just a click there. We must also realise that the solution doesn't lie solely in the design of new, more energy efficient buildings. The need to simultaneously address existing buildings is clear from the fact that about 80% of the buildings that will be around in 2050 already exist today. Next slide, please. So a dual approach to delivering a net zero carbon buildings is therefore required. However, there's another sometimes overlooked benefit of taking a longer term interest in building operational performance way beyond project handover and delivery. Click there, please. And that's that evidence-driven design based on lessons learned from new buildings simply won't get us to our destination fast enough. It's too slow. We need to be learning as much as possible from existing buildings to feed back into the design process with minimum delay. And Emer Maloney in the next talk will give a great example, practical example of just how what that can look like. Next slide, please. So it's all about evidence-based design and operation. However, this shouldn't immediately drive us towards technology-based solutions. As Emer will also discuss, Evidence based on experience is a great place to start the journey. People who, through learned experience, understand building design, the operation of building engineering systems, and the interaction between people and buildings are invaluable assets to the net zero carbon crusade. However, evidencing the effectiveness of any remedial actions and thereafter refining systems beyond the gains achievable by experience-based evidence will, at some point, require hard evidence of performance that only technology-enabled solutions can provide. Next slide, please. Also, additional considering strategies focused on delivering net zero carbon outcomes, we mustn't forget that buildings exist for people. Buildings are the building blocks of today's societies. But delivering human-centric outcomes, as Steve mentioned in the introduction, can conflict with delivering planet-conscious outcomes. And experts must therefore work hand in hand with technology-derived evidence to strike an appropriate balance and to best manage those tensions so that the best possible, holistically sustainable outcomes are delivered. Next slide, please. So, with such a complex, multidimensional equation to be solved, some means is needed of making accessible the right information to the right people at the right time. Using this information, decisions as to what outcomes need to be achieved can be based on robust evidence. Actions which focus on delivering those outcomes can be taken and, importantly, the effectiveness of those actions can be validated. What's imperative here is that the need for evidence doesn't become a roadmap to technology deployment for technology's sake. The robust evidence required to drive and deliver tangible real-world outcomes must ultimately be based on purposefully deployed technology which delivers fit-for-purpose data, no more and no less. So before I hand over to Emma Maloney to talk about existing buildings, I'd like to end this first talk with a short animation. I hope this will provide a useful overview of the issues currently facing the complexity of the built environment. And I also hope that the orchestral analogy will act as a helpful image to keep in your minds as we move through today's talk. Thank you.
Most of us now know that insight-led engagement with buildings is fundamental. By knowing what can be optimized, we can be instrumental in the global challenge for better health and well-being and a zero-carbon built environment. But how do we begin to build that insight? Consider every instrument that makes up an orchestra, each a complex piece of engineering, of craftsmanship. It can play its part in a symphony of sound that's harmonious and executed to perfection. But that perfection is hard to come by. It needs every instrument responding to one another, reacting to a conductor who sees the whole picture, someone who expertly holds the entire orchestra in their hands. For too long, data in buildings has struggled to be harmonious. And if it's not inaccessible, it's most often in chaos. Conflicting requirements, contradictory systems, and technology products that fall at the first hurdle have created a cacophony of complexity. The data needed to be able to understand our buildings might come from many different sources, but it needs people who understand how it works together. This data is crying out for a conductor who can not only access these individual instruments, but see how they can come together to be more than the sum of their parts. And most importantly, they must understand the people behind instruments, humans who think, feel, and bring their own unique viewpoints to bear. Solving these problems, this conductorless data, can only be done when technical know-how goes hand in hand with trust. This is the step towards true harmonious insight, allowing us to refine buildings to be the best they can be, for the people in them and the planet around them.
Thank you, Andrew. I'm going to talk about how successful measurement in conjunction with proper management will lead to successful buildings. And I want to kick off today with a couple of questions. Firstly, do we know what we are already measuring in existing buildings? And secondly, what are we doing with this data? Sometimes we're so focused on getting more and more data in the buildings that we actually forget to sit back and look at what we already have. We can't see the woods for the trees here. And when you do this, when you look back at what we already have, there actually is a lot of data there already. The reason that we're not looking for more, or that we are looking for more, is that we feel and we feel like we need more, is that we're not using what we already have. My name's Emer Maloney, as mentioned earlier. I'm a director and head of building performance for Horley, and I've worked in building performance for over 20 years. And in that time, I've learned a lot about what makes a building perform well. And yes, one of the key ingredients is data. Buildings produce a ton of data. A typical building built in the last 10 to 20 years will have thousands of data points. Mostly this is through the BMS, but also this can be from other sources like those listed in front of you. The amount of data already in existing buildings is significant. So my first bit of advice would be, before you start gathering more data and putting in bits of kit to gather this data, just take a step back and understand what you already have. This does rather lead on to another question though. If this data already exists, and as Andrew mentioned earlier, and we agree it's essential to highly performing buildings, then why aren't we using it? In my opinion, a major contributor to this is the lack of importance placed on building facilities teams. What we see time and again is that building owners accept the bare minimum when it comes to building maintenance. And this is a common occurrence across all regions of the high performance buildings group. Maintenance teams are contracted to, in essence, tick boxes and to make sure things function and we get no complaints. And while building owners might mention that this decision is financially driven, and I think that's true in part, but I do also believe that it's culturally driven. I have written a thought piece about this for Horley as part of our Insights publication if you want to find out a bit more about it. But in summary, what we do need to do is get more out of our maintenance teams. And we don't do this by just throwing money at it. Money is a part of it, but we also need to change how maintenance is thought of. For instance, we shouldn't be putting maintenance teams in windowless basement rooms, which we see all the time. FM teams have huge amounts of knowledge and potential, and we need to unlock this. And we can do this by investing in their training, listening to their ideas, giving them the resources that they need, and putting them front and centre in buildings. Because it's only once we have this engaged and knowledgeable team at our disposal that we'll find the data analysis and understanding much more effective. And the urgency with which we need to do this is becoming all the more important with the advance of net zero carbon. Andrew explained a bit about the net zero carbon and how to decarbonise buildings shown here. In summary, these are the 5 steps that we have to get an existing building to net zero carbon, which I won't run through right now because they're all important. But the step I'm most interested in, and the step that our expertise is frequently sought in, is step 2. So step 2 involves looking at buildings' energy consumption and finding ways to reduce it. And reduce it significantly. So the energy targets for existing buildings are really low. They can't be reached just by changing to LED bulbs or turning a thermostat down. We need to do a lot more than this. And to understand what we need to do requires a deep technical knowledge of building systems and their performance. So as an example, next slide, please. Thank you. This is a GLUMAC project for California State University. And along the second column, you'll see the list of energy efficiency measures needed across the estate. To a non-engineer, a lot of this will mean nothing. Yes, LEDs are there, but they're only one part of a much bigger solution. These solutions were derived from a combination of data gathering analysis and maintenance team engagement. We make it a goal in every project we do to discuss our proposed solutions with these maintenance teams, because what we find is that in a lot of cases, they've already thought of similar ideas and have gone through the thought process of how they could be implemented. And as a side note, I think it's worth mentioning the absolute value of producing this type of dashboard that you see as a way of helping building owners understand scenario planning. And we're using these more and more these days as a way of helping clients understand very technical situations. So back to the importance of data. I wanted to run through a real life example of the importance of data in an existing building. And this is what Steve mentioned earlier about heat pump sizing. So we have a scenario, this is a real life example I'm going to run through. It's an existing gas boiler system. And what we want to do is replace it with a heat pump system. For those that haven't come across this before, heat pumps are very high level and electrically fed form of heating. And it's how we get a lot of buildings decarbonised and off fossil fuels. So we're doing these a lot now, and we're going to be doing loads more very shortly. And when you start on a project like this, one of the most important questions we have to answer is what size of heat pump system we're putting in. In this case, we have a gas system that's capable of delivering 2 megawatts of heat. So the obvious thing to do would be to replace it with a heat pump system that can also deliver 2 megawatts. But let's take a step back a minute. If we talk to the maintenance team and look at the data, we can answer a better question. What does the building really need? The maintenance team has mentioned to us in this building that only one of the existing 4 boilers ever runs at any one time. And from our metering data, we can deduce that the highest loads incurred and when they incurred, and we can find that over a period of a few years, the maximum output ever needed was 800, move on to the next slide, was 800 kilowatts. Thank you. So that's less than half the installed capacity. So we look at installing an 800 kilowatt system, but that doesn't quite tie up with what the team mentioned. So only one boiler ever ran, and actually one boiler in this building is only 500 kilowatts, which is less than 800 kilowatts. So that requires us to dig even deeper. And what we start to now ask ourselves is how often do we need the 800 kilowatts? Our data shows us that only 2% of the time is this 800 kilowatt needed, and actually for 98% of the time, the building only ever needed, next slide please, less than 500 kilowatts. So we've just gone from thinking that we need a solution to deliver 2 megawatts to one that only needs 450 kilowatts for 98% of the time. And so now our solution looks totally different. We could install a 450 kilowatt heat pump system and then cover the 2% in other ways. There's loads of ways to deal with that 2%, which I won't go into now. But the message here is that by interrogating the data, speaking with maintenance teams, and understanding that building, we now have a solution that has a smaller electrical supply, requires less space to fit in, costs less to run, runs a lot better and more efficiently, so will last longer, and all importantly, costs a lot less upfront. And as we all like saving money, I have put some numbers against it on the next slide. Very roughly, these are UK numbers now. Going to 800 kilowatts from 2 megawatts will save roughly £300,000. Going down to 450 will save roughly £450,000. So significant amounts of money. In the short time I've had today, I hope I've convinced you of the benefits of combining both building data and building knowledge. In order to get you to start thinking on how to take these ideas forward, I've got a couple of examples I'm just going to end on of good practice lines who already get this. So firstly, next slide please, we have Legal in General. So Legal in General really understand the importance of good FM and complexity of modern buildings. They've set up a bespoke contractual arrangement with FM teams at the heart of it, and we have an ongoing contract with them to continuously offer support and advice to improve their building performance across over 40 sites in the UK. But we don't do this alone, and we work alongside the FM teams and data gathering and analysis software. So this project's been running for 3 years now, and it's been hugely successful. Tenants are happier and buildings are performing better. And then to end, thank you, on a project we completed several years ago. Here we optimized controls across 20 buildings on the University of Oxford estate. This was a one-off project and had a different aim to the previous example. So in this one, the aim was solely to reduce carbon. So the funding methods were different and the contract was different, but the outcomes were nonetheless as impressive. The impact in this project was an annual saving of 2 tons of CO2 from being emitted into the atmosphere, a payback of less than 1.5 years. But what I'm most proud of, we did all of this without the building users noticing anything at all. That's it from me. Thank you for your time. I'm going to hand you over to the next speaker.
Thank you, Emma. That was fantastic. A really good illustration of how experience-based evidence, you just don't throw out the baby with the bathwater. However, when we come to designing new buildings, it's important that we technology-enabled data correctly. So I'm handing over now to Cameron from NDY, who's going to talk about application to new buildings. Cameron, over to you.
Thanks, Andrew, and thanks, Emma. And I'd just like to reflect on a couple of points that have come up already in this session. The first of which is that technology can become a lot like an orchestra without a conductor, and that our outcomes here matter, and that evidence is everything to support that. So I'm Cameron Sandell. I head up the NDY digital team at a global level, and obviously I'm part of the High Performance Buildings Group, working with our other colleagues at Hawley, Glumac and Costantini. The teams that we have within the High Performance Buildings Group are globally distributed, and we do have regular collaborations around that. The types of services that we offer in terms of design work relate to audio, visual, ICT, comms, smart buildings, security. So when you put all of those component parts together, we really operate in the sweet spot, I guess, of what we refer to as either intelligent buildings or smart buildings. And these can be significantly helpful in the drive towards net zero. Next slide, please. So what is smart, or what is an intelligent building? And let's demystify a few buzzwords here. We quite often hear discussions in the market about single pane of glass, user journeys, smartphone applications, open protocols, data normalization. But what does all of that stuff really mean? So this diagram from Mamuri demonstrates the connection points, or the intersecting points, between technology streams, and where in a smart building those converging technology data sets might actually provide an outcome that is useful to a human. And you can see in this model that it's quite complicated. And to be quite honest, I actually don't think this goes quite far enough. I think it can be even more complicated than this. But hopefully we can simplify that for you and actually demonstrate a way of achieving this that is less complex, still very relevant and still very useful. So next slide, please. So how do we do a smart building or an intelligent building? We look at all the component parts, and I might actually start at the bottom layer, although I'll mention the top layer of this model first. So the top layer of this model is the presentation layer. This is the bit that you see on your desktop computer or your mobile phone or your public display kiosk or whatever it is. And that's the only bit that most people get to see. The magic of intelligent buildings and smart buildings actually happens below that. So let's start at the bottom of the model, the process layer. We're all reasonably familiar with the component parts here. These are your temperature sensors, your humidity sensors, your valves, your actuators, your CCTV cameras, your intruder detection devices, PIR detectors, brake glasses, and so on. All of these devices sit within what we call the process layer. So if you can imagine everything in a building that has a wire connected to it. The layer above that is a network layer. Now this is where we want all of those devices below to connect to a converged network so that we have a single domain to protect from cyber risk. But we also have a single domain so that we can manage that network traffic and actually protect those process layer systems from being overburdened by requests for data. The communication layer above it, again, a discrete layer, is where we do the normalization of data. So we're taking languages from one system and normalizing it so it can communicate with another. And then the data layer is where we're putting all of that normalized data so that we can use it for a purpose. The application layer is where we can apply some business logic. So this is where we can apply a logical algorithm that might say if an event occurs in one system, say the CCTV system, we can trigger an outcome in multiple other systems. And we're doing that at a logical level, so we're not constrained by where wires are connected anymore. That application layer, incidentally, is also where we might bring in data sets that come from outside of built engineered services. So this might be around wellness or food and beverage offerings or Bureau of Meteorology information or room booking systems or audio-visual systems. And all of that data can start to give us opportunities to deliver new initiatives in those process layer systems that are creating our energy optimization and sustainability opportunities. Furthermore, it gives us the opportunity to measure the outcome from that and determine whether those initiatives worked. Next slide, please. So where do we start? We need to start with understanding the aspirations and understanding why we need to go smart. As I mentioned before, we've now got an opportunity to not be limited by where bits of wire are connected. So we can do logical connections between data sets, which means we can take information from a room booking system and use that to influence an outcome in the lighting control system, the air conditioning system, the vertical transport system, and so on. What that means is that we can now tailor the operation of the building to really suit the way that the building is going to be used. Furthermore, we can actually measure the way the building is used through technologies like people counting. which have some other benefits as well around pandemic threshold and minimum social distancing management. But we can control the performance of a building to really suit the way the building is being used. Next slide, please. So technology is an enabler of outcomes. The conversation around what we want to achieve in a building should never start with the technology. It should always start with the user experience and what it is we're trying to deliver for a human. But the byproduct of that is that we can, as I said, customize the performance of the building and the operation of the building to really suit the way the building is being used. And that becomes particularly relevant when we're working in a hybrid work mode, which we are at the moment, where we don't know from one day to the next whether the building will be fully occupied, 50% occupied or less. So having the ability to use technology like people counting, sensors or video analytics through a CCTV system to determine occupancy can give us new opportunities to deliver not only energy optimization, but also plant life cycle extension. Next slide, please. So the other thing that is relevant, I guess, and newsworthy right at the moment is cyber security and data security. A single network, a single converged network with operational technologies sharing that domain also means that we only have one domain to protect. Historically, each of these systems have existed individually, and each one of them has had an internet connection, which means that in any one building there may be multiple internet access points or mobile phone access points or modems in the old days. Now we're looking at a single domain. We have a single domain to protect, which also means we have a single domain to manage, and we have the technology to, I guess, determine in that network management whether we've got a device that has come online that we didn't expect, or that we don't recognise. So there are opportunities here for increasing our cyber resilience as part of the process. Next slide, please. So where are we headed for the future? As the slide here says, yesterday's future is today. So there's a lot of rhetoric out there in the market around IoT, and I do believe that is the way of the future, but it's not readily available for scalable deployment in a commercial world today. But in order to support that, and in order for that to be available to our buildings in the future, we need to consider the way that it works. So we're hearing a lot about MQTT as a communication protocol. We're hearing a lot about JBOD storage. We're hearing a lot about software as a service, APIs, all these things. They either exist today or they're being developed today, and they will be with us tomorrow. So we need to consider them in our designs and not rely solely on the things that are available on the market today. Next slide, please. So I'm going to leave you with one more thought just before I hand over to Tom, and that is that technology has never moved as fast as it does today, and it will never move this slowly again. Over to you, Tom.
Thank you very much, Cameron. That was excellent. Really, succinct overview of what's really a very, very complex problem. But if any of you have any questions as we were going through this, please do put them in the Q&A section or the chat, and we'll do our best to answer them. So before we get on to the Q&A at the end of the section, can I hand over to Tom Collins, who's Head of Digital Engineering at Hawley, who's going to talk, give you some ideas about his thoughts about the future. Tom, over to you.
Thanks, Andrew. Afternoon, everyone. So my name's Tom. I'm Digital Director at Hawley. I head up the digital engineering team. I've been with Hawley since January 2020, just as the world began to change forever. I guess change is key here. Our industry is changing more rapidly than it ever has before. Within the next decade, the way that we design and operate buildings will be unrecognisable. And whilst optimization of existing buildings is crucial to achieving net zero carbon, we also need to think about how we design new buildings so that they stand the best chance possible of achieving optimum performance right from day one and then through into the future. So I'd like to share just at a high level some of what we're exploring at Hawley and across the high performance buildings group from a digital perspective to drive this change. Firstly, why am I the one here talking to you about this today? I'm not an engineer. When I joined Hawley, I joined the industry as well. I come from a range of different backgrounds. So my background is digital focused. in a range of different industries and contexts. So I was raised in what I call the school of hard knocks, growing up in the world of fintech. And since then I've put together teams to deliver fantastic digital experiences that give the end user valuable insights in a whole range of different contexts. The reason I mention this is that whether I've been working in fintech, retail, renewable energy services, there's a common thread that's emerged for me. And that is that when you focus on bringing together disparate data sets, sorry, can I just move forward a slide or two? Thanks. So when you focus on bringing together disparate data sets, next slide please, and layer on top of that a fantastic user experience, you end up getting a better outcome for everyone. So both ingredients are vital, but too often one or both of those are ignored. So onto the challenges we face in designing a better built environment. Seismic shifts that are taking place and we're adapting to them. Whether we're talking about the need to deliver net zero carbon outcomes for our clients, or the need to ensure that disasters such as the Grenfell Tower disaster here in the UK never happen again, there are two conclusions that we can draw that give us the imperative to change as an industry. So just move that on slightly, thank you. So the first conclusion is that we must design and operate buildings for balanced and convergent outcomes. That is, outcomes which deliver benefits for both people and for planet. And the second conclusion is that the design work that we produce must be informed by evidence, and in turn the benefits must be tangible and provable through evidence. So it's no longer good enough to simply produce reports. We must be designers and engineers who can actually demonstrate outcomes based on evidence. And so therefore, what must we do? We must converge those two strands, and we have to have an end-to-end engagement with the whole property life cycle. So across the High Performance Buildings Group, we have a fantastic, diverse range of specialisms with an ability to operate at the forefront of both design and operation. But now is a time, and into the future now, where we need to bring all of these capabilities together on projects in a fully integrated way. It seems obvious, but it's something that historically the industry doesn't really do. But only through such a whole sort of life cycle engagement will it be possible to ensure that buildings do actually deliver their required performance for both people and planet. On to the next slide, please. As an industry, we need to recognise the complexities, not just of buildings, but also the interaction between those buildings. We need to welcome evidence of real world performance, good or bad, so that we can use it to drive better design and better performance. We need to adopt a high-level systems thinking approach to appreciate the whole story and to learn from both success and failure to always improve on what has gone before. So on to the next slide. Ironically, the emergence of 3D modelling and BIM has in some ways moved the focus actually away from systems thinking and instead focused on objects and geometry. I believe actually this is the wrong way to look at our design. Instead, we should be focusing on systems above all else. There's also an inherent problem in our industry when it comes to adopting that end-to-end approach to building design, delivery and operation, and it's a problem that other industries have also worked to overcome. We have a traditional and highly transactional approach historically to project delivery. It's based on files and folders. Information is gathered in all these different files and folders, and it's often lost during the handover of those files between the delivery stages. So what makes matters even worse is we then promote this transactional approach with its inherent data loss as somehow minimizing contractual risk. But what's really needed is a more integrated and interoperable approach, such that handover between project delivery stages retains all relevant and necessary information as a golden thread. Next slide, please. And it's not just the loss of information either. We create incredible inefficiencies when taking this transactional file-based approach. Our engineers and designers end up spending more time importing, fixing and exporting various file formats than they actually do producing design work. And of course, this has to change. And so let's turn those files over and see what falls out. Let's give it a shake. Instead of using things like Revit files, Excel spreadsheets, pockets of disparate information all over the place, let's look at design information as a whole and fully connected and contextual. So, from projects, sites, buildings, all the way down to individual components, simulations, calculations, we can collaborate at this much more granular level typically, maybe even in your web browser, without having to worry so much about file formats and interchange. So when we move to this model of collaboration on a single source of information, we're doing two things. Number one, we're enabling our engineering teams to see the whole picture and focus on what they do best: design, test, iterate, repeat, always accelerating through greater use of automation. And secondly, it gets better. We begin to design a knowledge graph, as we call it. So as the design progresses, this results in creating a design master whereby all information, all design information is accessed via that single source of truth, sometimes referred to, as Cameron said, a single pane of glass. And then if you click on the, in effect, a design twin is born. So long before the physical twin exists, and that's what I'm going to call a building from now on, its functionality then replaces the operation, replicates, the operation of the building being designed. So a significant benefit of this approach to design is its ready extension into the real world then, as a building is constructed and then moves into operation. So we can call this the asset twin. And effectively what we've done is produce a digital twin ready design, you might call it. Then of course, once the project passes through the construction phase and real world data can then be fed into this knowledge graph, you end up with a far more meaningful representation of the physical twin, the building as it exists in reality. But when we talk about digital twins, we often get stuck on its visible representation, whether it's a 3D model or an online dashboard, for example. In reality, the true value here is having an underlying data structure, form of a knowledge graph that represents the system design. Next slide, please. So that isn't to say that the ontology represented by a digital twin knowledge graph can't be overlaid and made accessible via a 3D representation, as shown here. This is an example of a school classroom. But 3D and geometry alone simply doesn't provide the insight within a digital twin that a true systems view can. So this is where we've been playing with showing both alongside each other, and this is where a knowledge graph driven design can really be impactful. So next slide, please. So to reiterate, if we as an industry are going to take on a much more connected approach between design and operation, this undertaking is made much easier through a single source of truth throughout the whole end-to-end process. I think back also to, if you remember Steve Jobs, when launching the iPhone, he famously talked about 3 revolutionary products: an iPod, a phone, a mobile communications device, with the audience gradually realizing that actually he was talking about just one product that does it all. And it's the same story here. We have a design twin, an asset twin, a performance twin, all driven by the same underlying data and all performing in harmony. And so one final point from me, a single source of information does not mean a single experience for the end user. A digital twin platform for use in building operation must be composable and geared towards the outcomes the twin is there to measure, which is absolutely what Cameron was talking about just now. And so at this point, I actually want to hand back over to Andrew, who's going to talk a bit more about composable digital platforms. Thank you.
Thanks, Tom, for that. Yes, can I take over from Tom? Can I have the next slide, please? And talk a bit more about building digital twins and where we are on the journey with that as composable platform solutions. And I'd like briefly to return to Tom's reference to the iPhone, which I think is a great example, because a lot of people think, can I get a building digital twin? Where do I buy one from? Well, let's think about the iPhone. I mean, would you expect to take a new iPhone out of its box and it to deliver exactly what was wanted? And the answer, of course, is no. The iPhone is a platform on which we install apps that deliver outcomes relevant to our individual needs. And likewise, would you expect to open the box of a building design package software to find a ready designed building? And of course, the answer is no. Building design is about providing unique outcomes based on unique end user requirements. And digital twins need to be thought of in exactly the same way. They're composable software platforms on which solutions to deliver specific outcomes actually need to be designed and delivered. They don't come ready out of the box. So next slide, please. under the bonnet, they achieve this, and as Tom referred to there about the ontology and the interconnected of the systems, digital twins achieve their outcomes. They replicate the real world, not just by mirroring the systems which contribute towards real world outcomes, but they faithfully replicate how those systems interoperate. Now, it's the interoperability and interconnectedness of systems that absolutely is key. So the defining feature of the digital twin is not in this image here, the 3D system image on the right, like we all might think of digital twins as representing, but actually the crucial part is on the left hand of the screen, which is the underlying data structure, the knowledge graph based on the building's ontology, which crucially includes the real world interconnectivity between those entities. Next slide, please. So just to give you a couple of examples to finish on, for the past 5 years, we've been operating our London office at Hawley as a living laboratory to test new technologies in a real world environment. And that's included the development of a digital twin of the office and trialing outcomes that we might utilize that digital twin to get improved outcomes from. And I'll briefly overview very quickly a couple of specific use cases. And the first concerns indoor air quality. And in this example, an IoT sensor located in our main conference room detects high levels of CO2 is there to detect high levels of CO2 as a proxy for poor air quality. Next slide, please. So the interconnectedness of the entities within the digital twin means that the multiple potential contributors to that poor air quality can be readily identified. And of course, those contributors might range from too many people in the room. It might be the engineering systems themselves are leading to the poor air quality due to poor performance or, blocked filters or whatever, or it might even be the external air quality. So immediately via that single platform, you can pull together all the interconnected attributes that might be contributing to a problem that has been highlighted by a single sensor. And next slide, please. So you need to think of that at 2 levels, and this is where this single pane of glass and contextualized information really comes into being. Because at the highest level, you can just, to your building operator, set an alert that says, hold on, there's a problem with CO2 levels in the main conference room, or there's a problem with a temporary fault in the AHU leading to that. So that's at the highest level. Next slide, please. But the beauty of the digital twin, because it has this complex structure underneath it, is it's then very easy to begin to delve into the systems that might be contributing or related to the problems that are highlighted, so that you can very quickly route your way back to the root cause of it, in terms of whether it's the engineering systems, external air quality, whether there's too many people in the room, or whatever. So in this case, by the way, a related case, we use this same information to incorporate into our COVID-19 driven desk booking apps for peace of mind of staff, so we could inform them of what the air quality actually was when they were coming into the office and make sure we could keep that social distancing in place in terms of occupancy as well through occupancy counts. Next slide, please. So as a second example use case, and as I'm flying through these, but hopefully they'll be useful just to provide you some insight as to the way we're helping drive outcomes for ourselves. The digital twin platform is being used to support development of our own roadmap to net zero carbon, and in particular, as Emma pointed out, assessing the energy performance of the building as it is, and then coming up with solutions for reducing the energy consumption and emissions of the building. Next slide, please. So in this case, the user interface on the composable platform, which is the digital twin, has been specifically developed to allow us as engineers and designers to interrogate the various energy meters to provide ready access to the evidence, and we've talked about evidence a lot in this. It is key, hard evidence required to inform our net zero carbon strategy. And the flexibility of the interface has been designed so that we can slice and dice the information in multiple ways. And again, the contextual nature of that is absolutely vital. You need to understand who's going to be using that information so that it can be readily accessible. Next slide, please. So we're also embedding, and this is something that Emma showed in her presentation about dashboards, existing analysis tools into the digital twin platform, such as this dashboard for developing our own roadmap to net zero carbon. And so you'll see down the left-hand side of that dashboard a number of options for action. Other information displayed includes the costs of implementation, calculated carbon reductions, and also how the cumulative effects of various actions may lead us towards our emissions target. Next slide, please. But what you have to realize here is the devil lies in the detail. Each of those actions' effectiveness depends on actual demand, which varies hour by hour, day by day, month by month. And it also has to be coupled with the real-time carbon intensity and cost of energy coming into the building from the grid. So all of those things combine in a really complex way. And behind the scenes, we need to be undertaking those calculations to really begin to refine the performance of the building with an understanding of everything that's feeding into the outcomes that we require, which in this case is to deliver our own roadmap to net zero carbon most effectively. So therefore is vital that we base those overall calculations on fit for purpose data that provides the necessary level of granularity, as shown in the second interface here. And as said at the start, it's important to get that granularity right and the source of data right, because we need fit for purpose data, and it has to be no more and no less, because otherwise things can get far too complicated. So this example shows the carbon savings based on a combination of daylight dimming and on-site solar PV generation. So as you can see in the bottom right-hand plot, which shows the energy reductions over the course of a typical 24-hour period, the major reductions occurring during daylight hours and during the summer months. And again, of course, as Cameron highlighted, access to real-time data enables the anticipated effectiveness of any actions to be readily verified. Next slide, please. So those are just two examples of driving better outcomes based on evidence. But in composing those solutions, we must be ever mindful of the intrinsic link between planet-conscious and human-centric outcomes, including the potential tensions mentioned earlier. So at the highest level, buildings need to deliver positive outcomes for people. They are cornerstones of a thriving and sustainable society, but in turn, society needs a stable and sustainable environment if it's to thrive. So we need to think of buildings existing as a series of often complex subsystems. And the one thing we mustn't forget is one of those component subsystems is people. And so whilst building performance impacts on human outcomes, human behavior equally impacts on building performance. So as we develop technology-based solutions, enabled solutions, this two-way interrelationship between people and buildings should never be overlooked. And we also should never ignore the interconnectivity between buildings and, of course, the wider environmental and societal ecosystems of which they themselves form a part. Next slide, please. So in conclusion, whatever outcomes we strive towards and whatever technology we may deploy to achieve those outcomes, the requirement would always be there for the conductors of the building, using that orchestral analogy again, whoever they may be, to be presented with the right information in the right way, such that they can take the right actions based on the evidence presented to them. And of course, they must be able to establish whether those actions have led to the desired outcomes. So next slide, please. If I can just close with our vision as a high performance buildings group for the buildings of the future, both new and existing, is that every building should be founded on a platform composed by experts. There should be a conductor or conductors who can balance and optimize the instruments within that building, such that the whole can serve as a foundation to enable better outcomes for people and planet. And with that, I'll hand back to Steve Strauss to sort of close the proceedings and introduce the Q&A. Steve.
Dr. Bullmore, what a spectacular presentation. And I think in part that sums up some of the benefit that we've had from the pandemic. We're able to work so much better together remotely. It's really quite amazing. And I think that speaks to the power of the High Performance Buildings Group as well. We've been meeting regularly every week and exchanging information, ideas among some of the smartest people in the world. So it's made our company certainly a much better company. Next slide. I did want to give a hint about our next presentation that will be in February, and it's going to be about delivering net zero carbon buildings and also about indoor air quality. Next slide. Next one. Yep. So in February 2023, go back up there. Yep. We will be having a presentation about indoor air quality. In March of 2019, we formed a COVID-19 task force, and we had weekly meetings. We had esteemed guests, including Dr. Michael Kaiser, he's an esteemed epidemiologist. We had the head of the ASHRAE Pandemic Committee, about 150 scientists and engineers on our calls each week. And we exchange that information so that we could provide the best intel to our clients, many of which had to work 24 hours a day, 365 days a year during the pandemic because their businesses required it. Through this process, we learned a lot about indoor air quality, including extensive testing and CFD analysis. And we're going to be presenting the results of that information in this indoor air quality presentation on 2023. Would like to close by responding to some of the questions we received from the audience and some of the ones we've developed ourselves. I think we got a Q&A slide here. Is that right, Sarah?
Thanks, Steve. If I actually just read out one of the questions that was actually put forward by the audience. So question number one, given that a large percentage of built assets already exist today, how do you start on the journey of deploying building intelligence when designing from scratch? Is it not possible as if on a greenfield site? And given that we seem to be putting the global pandemic behind us, have you seen any changes or differences to design occurring as a direct result of concern generated due to COVID? It's a long one.
So Cameron, why don't you take that first question about how do we deal with existing assets that already have a number of these systems in place, and what's the roadmap to improve them, Cameron?
Look, I think the answer to that question is probably quite broad, but in simple terms, the starting point is to understand what you've already got. To Emma's point at the beginning of her presentation, there's already a lot of systems and a lot of data out there in existing buildings, but we often don't know what that is, and we often don't use it because we don't know what it is. So starting point has to be, what have you already got? And I guess if we're looking to improve the facility in terms of its intelligent capabilities and smart building capabilities, we need to develop a roadmap and understand the gap between what we have got and what we would really like or what we need. So again, it is a design process, I guess, but it starts with what have we got, what are we missing, and have we got things that are compatible with a future state?
Can I jump in there and add to that, Cameron? Because that's absolutely right. I mean, one of the experiences we've been having with our own Western Transit Shed, our living lab, is of course, just because you've got data, don't assume that it's fit for purpose. That the amount of data that you can pull out of a building that is coming from uncalibrated systems is even coming from the wrong systems. So you absolutely need people like Emma's performance team and other performance team around the high performance building group who can understand that data and interrogate it to the degree where they can say, well, is that sensible or isn't it sensible? Because the worst thing in the world you want to be doing is driving outcomes based on evidence that isn't fit for purpose. We keep coming back to this point of fit for purpose data. I don't know if Emma, if you've got anything to add to that point, but to me that's absolutely key.
Yeah, it's really, I mean, you've kind of both nailed it there. There isn't, buildings are bespoke, every existing building. So there's not like one solution. So I'll say, oh yeah, you go in and employ this, and stick that in a building and you get what you want out of it. Every single building is different and it will have been run differently and it will have been designed differently. So you need to go in and understand the building and then figure out what you need from there. But often, to be honest, we don't deploy building intelligence in existing buildings, especially more modern ones, because there's enough stuff there. There's enough stuff that we can act on.
All right, a couple more questions. Go ahead, Dr.
Yeah, sorry, I was just going to add one more thing, which was to do with the COVID and the way buildings are being operated differently. One of the things we also have a interest in, buildings rated in terms of energy performance, kilowatt hours per square metre. Actually, we've got an increasing interest in kilowatt hours per square metre per person, because it's all very well having a really efficient office block or workplace, but if it's only 10 people using it instead of 100 and it's still using the same energy, we absolutely need to have a refocus on the use to which that energy is being put and the outcomes that are being delivered from it. So back to you, Steve.
You know, that's actually the question. I've seen so many owners come to me recently because unfortunately we're seeing very low occupancies in the office space. Sometimes 10 people where the space was designed for 300. So what are these owners supposed to be doing now in terms of providing good indoor air quality, but not spending so much money on energy? And, obviously they're trying to cut their costs, but also from a greenhouse gas perspective, we need to do things differently. So what should we be doing now, Dr. Bullmore?
Well, our view on that is the idea of, zoning office use is absolutely critical, and actually managing office space use. So again, coming back to our own office, it was designed for something like 200, 250 people, but some days it might have 20 people or 30 people in it. Now, if those people naturally distribute themselves around the whole office, all the systems are going to come into operation. We need to have demand-led systems, and we need to have managed systems so that if you've only got 30 people in the office, you only utilize the systems in that office that are needed to support those 30 people. So it really has to be driven by the evidence of occupancy, and that is absolutely key, and managing people's routes around the building. I don't know, Cameron, have you got anything else to add to that?
No, well, not just to expand on that last point you made, and that is that we can't manage what we don't measure. And we do have a situation, as you quite rightly point out, where we might have 10 people coming in to work in a space that was designed for 300. But if we don't know that, we can't do anything about it, right? So we can deploy technologies that will support those outcomes, and they're not necessarily new technologies. They've been used in retail for decades. But now all of a sudden we're finding a new use for them in commercial buildings, and that's around people counting. I guess the second part to that then is the influence or the integration of that data with other systems like the air conditioning control system or the lighting control system, to make sure that they're not just automatically starting up, based on a time schedule, that they are in fact starting up based on a time schedule and a demand that we can now measure.
I was just going to jump in there from
All
a
right,
very practical standpoint. Just very quickly, sorry, I won't go and talk too long, Steve, sorry. Just be careful with demand-led systems, because in theory they're great and they do work, but they do need an awful lot of fine-tuning. They're not plug and play, especially if you're turning down from 300 to 10 people. That's quite a big turn down ratio. Sorry, Steve.
Emer, the next question is for you, actually. And
okay.
There was a lot of discussion at Greenbuild about decarbonization, about switching to heat pumps. And everybody said, you need to do load counts. You can't just, put the new heat pumps in to match the boilers. But what we're finding is that's still grossly oversized. Is it, just as you mentioned in your presentation, what should owners be doing in terms of technology so they can monitor their boiler operations now and size the right type of heat pumps later, which obviously results in huge savings in the future?
Just meter what your building load is using. And actually, this is something that I speak daily to my clients about. We're coming into the winter here in the UK, and now is the time. A lot of people are planning to start heat pump replacement projects in the next few months. So, time's of the essence. They need to get these meters in now. And it isn't just, we can do a lot with half-hourly meters coming into a building, but really we need to know a bit more detail about kind of how that travels down the line. So sub-metering is really important as well. It will depend on the building and what's happening in there, how many you need and what type you need. But the metering is the key for that.
Excellent. And final question for Dr. Bullmore. I did attend this Greenbuild conference with 20,000 other people. What is the conference facility of the future going to look like? And maybe this is something Tom could add in too. Am I going to be able to see what the VOC and the particle count is in these different rooms? Am I going to see what the CO2 level is? Are we going to be able to have more, data for the occupants to see with? Because right now I don't see even the temperature in the room.
My view is I would certainly like to see that. I mean, it's something that we've been implementing in terms of accessibility of our apps, so that, if visitors are coming to our offices, they know when they're coming what the air quality is going to be like. And yeah, it should be direct feedback, and also managed. One of the schemes we've been looking at is a museum scheme where they actively want to manage people movement around the building based on air quality levels. So there's active signage and active feedback of air quality, so that they can minimize any hotspots of poor air quality. So absolutely, I think that should be part of the integrated systems of the future.
Tom?
And just to add to that, I mean, that's very much part of the obvious direction of travel that we're seeing around indoor experiences. You know, think even about going around a typical supermarket in the UK, you're starting to see digital twin counterparts of the layout of the store. You kind of know which aisle to go to based on the app on your phone. You know, navigating around airports becomes something you start to use your phone more for. Even, you know, going to conferences, you're supported with that digital counterpart. So it's a very clear direction of travel we're seeing. And as you know, whilst we talked about every building is different, the ability to map it, to be able to kind of create digital spaces that replicate existing buildings, and also, of course, as I was talking about earlier, to be able to bring not just system design, but also 3D geometry left over from the design assets, the ability for us to produce real world digital counterparts to the existing building, the physical twin, is going to be commonplace. It's a much easier operation with all of that data to hand.
Perfect. Well, I want to thank all of those that attended today's presentation. I look forward to seeing you guys in February when we do our next one in indoor air quality. If you put questions into the chat box, we will be responding to those with an email. We have recorded the entire presentation, and we will be forwarded to the people that attended and others that would like to see a copy of it as well. You can just send an email to Sarah, and she'll be glad to connect you with a link to the presentation. Thanks so much again, and we'll look forward to seeing you again in February. Have a good one, everyone.